Knowing your genetic blueprint is key to your health. Hi, I'm Dr. Nate Handley, and today I'm going to talk about genetic blueprints. This is one of the tools that I frequently use to help people understand their health, and I want to explain what they are and how they help. The human body has over 20,000 genes that form the basis for how you show up in the world. These genes regulate all kinds of things, from hair color and eye color to risk for certain diseases. Many of these genes have common variations called single nucleotide polymorphisms, or SNPs, that can change their function. Different types of SNPs have different degrees of impact. Some SNPs are called high penetrance, which means that if you have a particular gene variation, that gene is likely going to be very relevant for you. High penetrance SNPs that affect health are usually rare. One example are SNPs in the BRCA1 gene, which are present in only about 0.2% of the population. Some BRCA1 or BRCA SNPs are associated with a significantly increased risk of developing breast and ovarian cancer. The risk might be 10 times that of someone without the gene. So people with variants in BRCA1 have a lifetime risk of breast cancer that can be as high as 72% by age 80, and a risk of ovarian cancer up to 44% by age 80. Other genes have SNPs that are called low penetrance. These gene variants are usually common, which means that just because you have the gene doesn't mean that you'll have issues associated with it. One example of this is a gene called MTHFR. MTHFR is involved in folate metabolism, and most people, at least 50% and maybe even 70% of the population, have at least one copy of one of an MTHFR variant. But it's not the case that 70% of the population has a problem with folate metabolism. Now, it's possible to look at all of the genes a person has in isolation and think about what effects each of them may have the potential to create. But the body is more complex than that. Traditional studies looking at individual genes have identified lots of SNPs associated with various diseases. But these explain only a small fraction of disease that is likely linked to genetics. There are many reasons for this, but one of the most important ones is that single genes are typically involved in many different processes in the body. And processes in the body involve many different genes. This is why it is helpful to look at genes not only by their individual effect, but also by their relationship with other genes in the body. This is where genetic blueprints come into play. A blueprint is a guide for making something, like a house. When you think about making a house, from a blueprint, you have to understand each of the parts of the blueprint individually. But you also have to understand how they relate to one another. You need to know the size, shape, and materials used in the kitchen, for example. But you also need to understand how the kitchen connects to other parts of the house. The same is true for the body. A genetic blueprint looks not only at individual genes, but also at how these genes connect with one another. Pathway-based genetic testing is the best tool we currently have to understand your genetic blueprint. This approach is based on the understanding that complex traits and diseases often result from the interplay of multiple genetic variants within biological pathways. A biological pathway is a set of processes in the body that regulate a particular quality, something like inflammation or detoxification or weight management, for example. Pathway-based approaches enhance the power of genetic analysis by combining the effects of multiple functionally related genes. By focusing on pathways rather than individual genes, this approach can better capture the cumulative impact of SNPs. This strategy can be helpful for many things. For example, by combining the effect of many SNPs across the genome, it is possible to estimate an individual's genetic predisposition to conditions like excess inflammation, cardiovascular disease, cognitive impairment, lots of things like that. Now, it's all well and good to have a sense of risk, but what's really important is that this approach can actually help you develop precise, personalized strategies to understand how to best support your body. Not everybody needs the same thing. We all have different blueprints. What's the first thing you try to do if you're trying to build a house? Study the blueprint. What's the first thing you should do when you're trying to improve your own health? Study the blueprint. There are readily available tests that can help you do this, and working with an integrative or functional medicine practitioner can be a great place to start.